In this video, I will be discussing how you solve absolute value equations. To solve any absolute value equation, if you have the absolute value equal to a number c, we first have to recognize that c must be greater than or equal to 0. This is because the absolute value must be either 0 or positive because we're talking about distance from 0. So if c is ever equal to a negative number, then you can't actually solve the absolute value equation. But if you want to solve the absolute value equation and c is greater than or equal to 0, then you want to actually split the equation up into two different equations. The first equation really just drops the absolute values, so you just have ax plus b equal to our c. The second equation, you still drop the absolute values, but now it's set equal to negative c. So this is how we get rid of the absolute values. Then you can go ahead and solve each of these equations separately. You should get two answers for your solution. These are the steps that we want to follow when we're solving absolute value equations. We first want to isolate the absolute value. So as you saw in the last slide, the absolute value was by itself equal to a number c. So we always want to get that absolute value by itself. Then we want to split the absolute value into those two equations that I showed you, and then you can solve each of those equations separately. In this first example, I noticed that the absolute value is already isolated. There is no times 2 out front, divided by 5, or even minus 7 attached to it. It's just the absolute value. So we can go ahead and skip step 1 since we didn't have to do anything there. It's already isolated. Moving on to step 2, we want to take that absolute value and split it up into two different equations. The first equation, you just drop the absolute value symbols. Everything else is exactly the same. In my opinion, this is the easiest one to do. The second equation, you're still going to drop the absolute value symbols, but now you're going to set it equal to the negative of whatever the number on the right-hand side is, in this case 6. You'll notice that this number on the right-hand side should never be a negative number because the absolute value can never be equal to a negative number. Absolute value is always a positive number. So your first equation will always just be dropping the absolute values, and your second equation will always be the same thing, except now you have the negative number in there. So now that we have split the absolute value into two equations, we can go ahead and solve each of those equations individually. To do this, we want to add 4 to both sides, and that'll be the same for both of those equations. And then we can simplify. We'll get x equals 10 or x equals negative 2. So these are our two answers, solutions to the absolute value equation. And just like if we were solving equations, you can actually take both of these answers and plug them in one at a time and show that you do get a true statement. So let's try that for this example. If we plug in 10, we get 10 minus 4 in the absolute value equals 6. Well, 10 minus 4 is 6. And we do know that the absolute value of 6 is 6. So yes, that gives us a true statement, meaning 10 is a solution to this absolute value equation. We can do the same thing with x equals negative 2. We plug in negative 2 for x, and go ahead and simplify the left-hand side. We'll get negative 6 inside the absolute values. And the absolute value of negative 6 is 6. And yes, 6 is equal to 6. So negative 2 is a solution to this absolute value equation. For this next example, you'll notice that the absolute value has that minus 10 attached to it. So we actually have to get rid of that minus 10 before we can go ahead and start splitting up the absolute value. We have to get the absolute value isolated by adding 10 to both sides. And when we do that, we have the absolute value of 3x plus 9 equal to positive 6. So now that absolute value portion is all by itself. So we've completed step 1, and we can move on to splitting the absolute value into two different equations. So again, to do that, the first equation, you just drop the absolute value symbols. So we have 3x plus 9 equals 6. And the second equation, you're still dropping the absolute value symbols, but you're taking the opposite of the number it's equal to. So we're going to set it equal to negative 6. Now that we have split it into two different equations, we can go ahead and solve each of the equations individually. For the first equation, we can subtract 9 from both sides to get 3x equals negative 3. And then we can divide both sides by 3 to get x equals negative 1. And solving the second equation, you're going to go through the same steps. So you're still going to subtract 9 from both sides. But now we're going to get negative 6 minus 9. That's going to get us negative 15. And then we can still divide both sides by 3 to get x equals negative 5. So these are the two solutions to our absolute value. And if you wanted to plug those back in to see if you get negative 4, you will notice that both negative 1 and negative 5 work in this situation. This next example might be a little bit more complicated, but again, we still want to follow our 3 steps. The first step is to get this absolute value by itself, which means we have to get rid of this minus 3 and this negative 2 out front. To do that, we want to add 3 to both sides. So we have negative 2 times the absolute value of 5x plus 1, and that's going to be equal to negative 8. So that got rid of that minus 3. Now we want to get rid of the minus 2 out front, and to do that we want to divide everything by negative 2. That's because the minus 2 is being multiplied by the absolute value, so you want to undo the multiplication by dividing. That is going to leave the absolute value by itself, and that's going to be equal to positive 4. Now that we have the absolute value by itself, we can then split it up into our 2 different equations. So we drop the absolute values in the first equation, and then we drop the absolute values in the second and take the opposite of the number that it's equal to. So in this case, negative 4. Now that we have split it up into our 2 equations, we can go ahead and solve each of those equations. So we can subtract 1, and then divide both sides by 5. And it is okay if you have a fraction. We just want to leave it as a fraction. Fractions are a little bit more exact than decimals, which is why I do like to keep everything as fractions in simplest form. And then we can solve the second equation, again by subtracting 1 from both sides, and then dividing by 5. Right, so our second answer is x equals negative 1, and that's it. We have solved both of those equations. So each of these should, when you plug them back in, they should get you a negative 11 when you simplify the left-hand side. On to our last example. Again, we have something a little bit more complex, but again, we're just going to take it one step at a time. If you ever need to, you can just kind of locate your absolute value and figure out, how do I get rid of everything else? To start, let's subtract this 7 away from both sides to get rid of that plus 7. When we do that, that plus 7 will go away. Everything else will be the same over on the left-hand side. And then we have 11 minus 7, which is 4. You can either get rid of this 2 first or get rid of the 5. Really kind of however you want to do that. I'm going to get rid of the 5 first by multiplying both sides by 5. And when we do that, the 5s are going to cancel over here, and then we have 4 times 5, which is 20. And to get rid of the 2, you can divide both sides by 2. You didn't have to divide and multiply in the same order that I did. You could have even multiplied both sides by 5 over 2, since that kind of does the multiplication of 5 and division by 2 all at the same time. It's really just up to you. But now that the absolute value is by itself, we can split it up and then solve each of those equations. So again, we drop the absolute value in the first one, and then we again drop the absolute value and take the opposite of what it's equal to, which would be negative 10. And when we solve, we first want to subtract 2. We get 3x equals 8. And when we divide both sides by 3, we get x equals 8/3. You can leave this as 8/3. You could also make it a mixed number. So this could also be 2 and 2/3, really however you want to do that. And we can go ahead and solve the second equation. We get 3x equals negative 12 and x equals negative 4 when we divide both sides by 3. So again, we want to put that or in between because we can't plug them both in at the same time. Either this solution will work when you plug it in or this solution will work. You can't plug them both in at the same time. So we do want to have that or in between. And so we have that negative 4 and our fraction or mixed number for the 8/3. And again, to kind of recap the steps that we've been using, you first want to isolate your absolute value, get it all by itself by using your inverse operations. Then you want to split up your absolute value into two different equations, both by dropping the absolute value bars, but setting them equal to opposite numbers. So again, in that last equation, the first one was equal to 10, the second one was equal to negative 10. And the last step would just be to solve each of those equations individually. And if you ever want to go back and check your answers, you can just plug in each of those answers to the original equation and see if you get a true statement when you simplify. And that is how you solve an absolute value equation.